Welcome to the 5th lesson of the Bonding, Structure and Properties of Matter topic. In this topic, the key questions are 1. What are the properties of ionic compounds? 2. What are the properties of small molecules? Key terms that you need to be familiar with: ionic compounds, small molecules. In today's lesson, we will talk about the properties of ionic compounds and molecules. Solid materials can form different types of crystals depending on the chemical bonds and the intermolecular forces. The 4 main types of crystal are 1. Ionic, 2. Metallic, 3. Covalent, 4. Giant covalent. Task. Now please pause the video and describe the main differences between the different crystal types. Hint: look at the diagram above and also think about which types of elements form what type of crystals. Extension: name examples for each. Now let's discuss this question in detail. We have covered that the majority of the elements are metals. Metals either form ionic compounds with non-metals or form metallic bonds with metals. Group 5, 6 and 7 elements plus hydrogen from group 1 can form covalent bonds, which would make covalent crystals. Covalent crystals have low melting points as molecules are held together only by weak intermolecular forces. Metals and ionic crystals have a high melting point due to the strong electrostatic interaction between the oppositely charged ions and, in the case of metals, the electrons and the metal ions. Giant covalent crystals have the highest melting point as atoms are joined together with strong covalent bonds. Examples: covalent crystal, iodine. Ionic crystal, sodium chloride, potassium chloride. Metallic crystal, magnesium, gold. Giant covalent, graphite, diamond. Metallic bonds mostly happen among the same type of atoms, but can happen between different atoms too. These compounds are called metal alloys. Molecular covalent structure is formed by weakly bonded molecules like water. When water freezes, it forms different shapes of crystals depending on the cooling speed and the surrounding temperature. One example is shown here. When diatomic molecules, like iodine, are bonded with weak intermolecular forces, they can also show a range of crystal structures. We have learned about metallic and ionic crystals. Task. Now please pause the video and think about how conductivity applies to all crystal types. Hint: conductivity is related to freely moving, charged particles. Extension: what energy changes are associated with each type? Conductivity is always related to freely moving charged particles, ions or electrons. In covalent structures, there are no freely moving electrons or ions. Therefore, they never conduct electricity. This is why iodine crystals are insulators. However, giant covalent structures are not always insulators. In graphite, there are layers that can slide on each other. Between these layers, there are many freely moving, delocalized electrons. Therefore, as a consequence, graphite conducts electricity. Ionic crystals have ions in fixed positions. Therefore, as crystals, they do not conduct electricity. However, when melted, the ions will start moving freely. Therefore, molten ionic crystals will conduct electricity. The order of energy stored in crystals is covalent, metallic, ionic, giant covalent. This means that the energy associated with melting crystals follows this order too.